Welcome back. In this video we will examine further the user interface, begin navigating through the various tool palettes, and modifying some basic settings. Communicating with the AutoCAD software is best thought of as a conversation with the software. We interact with the machine via our keyboard inputs in either the command line or in dialog boxes. Likely, the most often used key on your keyboard will be the Escape key. At any point the user wishes to exit a command or otherwise stop a process, hitting the Escape key is the most effective and direct means. From a drafting perspective, the best analogy is to think of hitting the Escape key as putting the pencil down. We also interact with the machine with our mouse. A 2-button mouse with a center scroll wheel is optimal. The majority of our mouse inputs are done with the left mouse button. For example, selecting tool icons or pulling down and expanding menus is achieved with left mouse clicks. Right-clicking on our mouse presents us with a default flyout contextual menu. This menu contains certain often used tools and presents certain command-specific options. This menu will automatically modify and populate with options that support a given command the user has invoked. We will explore the most commonly used items in this menu now, leaving others for a later time. At the top of this menu there is a repeat prompt, which will be followed by the most recently used command. As we have just opened our software program, the last command given was an internal command by the software to open the command line. Hovering over the recent input prompt, we see that command line and ribbon are the two most recent commands used by the software in this drawing session. This list will be further populated as additional commands are accessed and used. Left-clicking on a previous command in this list will re-invoke that command. As previously discussed, AutoCAD offers multiple means of invoking commands. This recent input list provides one of these methods and alternatives. Hovering over the clipboard prompt, we are presented with a flyout menu with some very common copy and paste commands. Using the cut command removes a selected object from your drawing space. Copy makes a copy of the selected object, which is retained in your computer's random access memory and available to be pasted elsewhere. Copy with base point is a manner of selecting and copying an object using a specific location on or adjacent to that object. Base point is a commonly used term within the AutoCAD software. The best way to think about the term base point when prompted is to internalize the words base point to mean at which point or location am I holding this object. Selecting Paste allows the user to paste a copy of the last object copied and saved in the machine's random access memory. We will visit the Paste as Block or Paste to Original Coordinates later when we explore creating and using blocks. Next in this flyout list is Isolate Objects. As a drawing develops and more objects occupy the workspace, this tool allows the user to temporarily isolate or separate out a singular or select group of objects to make modifying or otherwise working with them visually easier to accomplish. Once the user has completed working with the isolated objects, accessing the right-click flyout menu, navigating to isolate objects, and choosing End Object Isolation unhides the hidden objects. Selecting Undo Command Line is a duplication of the Undo command arrow we found in the toolbar at the top of our display in the previous video. Likewise, redo reinvokes the last command or step that was undone and is also duplication of the redo command arrow we find in the toolbar at the top left of our display. Selecting the pan command changes our cursor on our display to a hand. With this command enabled, clicking and holding down our left mouse button allows us to pan our workspace to reveal other portions of our work environment. The pan command is most easily accessed and alternatively accessed by pressing down and holding the center mouse wheel. Selecting the zoom command changes our cursor to a magnifying glass. We can zoom in to look closer at our drawing space objects or zoom out to see a larger area of our workspace. We do this by rolling our scroll wheel forward to zoom in and rolling our scroll wheel backwards to zoom out. What is important to remember is that the focus point when zooming in and zooming out occurs at the point where your cursor is located within the drawing space on your display. At the bottom of this flyout menu is the Options command. Selecting by left-clicking here opens up the Options dialog box, within which various file and drawing management options reside. This is similar to a Preferences or Settings menu common to all software. We will come back to this Options menu in our next video. The command line, by default, lives at the bottom of your display. It is in the command line where the user interacts directly with the software, either by typing in keyboard commands or responding to or selecting options that are subcomponents of a given command. Again, one can think of this interaction as a request and response type conversation. At the far right end of the command line is a contextual menu arrow. Selecting this arrow allows for the command line to expand and reveal the history of commands and data input of the current drawing session. This history is extremely helpful in that we sometimes execute a command, but what we see on our display is not what we were expecting. Most often, this is user error, such as typing in an incorrect numerical value. Let's shift our focus to the bottom left corner of our display. We see three tabs. One is called Model, the others are called Layout 1 and Layout 2. We use these tabs to navigate between our model space drawing environment and our drawing sheet layouts. The model space drawing environment is a virtual infinite drawing universe and is what we are currently presented with on our display. Given that there are no size or volume constraints within this environment, everything that we draw in model space, we draw at a real 1-to-1 scale. The two tabs, Layout 1 and Layout 2, are representational drawing sheets or drawing paper environments. Since we draw all of our objects in model space to their true real size and dimensions, it is in these paper space environments where we view and appropriately scale our objects so that they can be presented in a printed layout. We will visit these layout tabs later in another video. AutoCAD is a vector-based program. This is to say, all locations within our drawing model space have relative spatial or Cartesian coordinates in the X, Y, and Z directions. One might wish to consider the center of this model space drawing universe as the coordinate point 0x, 0y, and 0z. By zooming out and panning our display, we can see that there is a horizontal red line and a green vertical line, and at the location where these two lines intersect is the coordinate point 0, 0, 0. We also see at this location an icon that indicates the X and Y coordinate planes. This icon is called the UCS icon. UCS stands for the Universal or User Coordinate System. Since our model space drawing environment is truly three-dimensional, let's quickly explore how to view this environment from a different orientation using the view cube, which is located in the upper right corner of our display. Note there is a compass ring around a square in the center, which is currently labeled top. As the label infers, the view cube is a six-sided box having a top, a bottom, a left and right sides, as well as a front and back side. As in all drawing and drafting environments, the top view is equivalent to the user looking straight down from above, also known as the plan view. And as we move our cursor and touch the corners and edges of the view cube, we note that each corner or edge highlights in blue. Selecting the small blue highlighted square at the bottom left corner of the view cube reorientates our view to the southwest isometric view of our model drawing space. In this orientation, we can now see the Z direction indicated on our UCS icon. We also see on our view cube the word left on the left-hand side of the cube and the word front on the front side of this cube. We also note that our cursor now displays a red line in the X direction, a green line in the Y direction, and a blue line representing the Z direction. By placing our cursor over the word top on our view cube and left-clicking, our model space drawing environment is returned back to the top or plan view. Allowing our cursor to hover over the view cube or compass reveals to the upper right two arrows, one pointing in the counterclockwise direction, the other in the clockwise direction. Selecting either of these arrows will rotate the current display of our model space view 90 degrees. As we have noted previously, in AutoCAD there are multiple ways to perform any given command or task. An alternative to using the view cube to reorientate our view, at the far left side of our display, we see the word top in squared brackets. Similar to the word top displaying on top of our view cube, the word top at the left side of our display also indicates the current orientation of our drawing environment. By left-clicking on the word top here in the upper left, a contextual menu will expand, displaying the common plan, elevation, and isometric drawing views. Just to the right of this View contextual menu is a contextual menu that allows us to modify how objects can be visually displayed. The majority of these controls are most useful when visualizing three-dimensionally modeled forms such as solids, surfaces, and meshes, which we will explore in a later video. Across the top of our display is what is known as the ribbon. The ribbon consists of a series of tabs, and within each tab, a series of panels. Starting at the upper left end is the Home tab. The Home tab consists of panels of the most often used tools in the AutoCAD software. Some of these panels are subsets of tools more broadly contained on other ribbon tabs. We will explore other tabs and other tools in future videos. The Draw panel contains tools for creating basic geometric line work and other drawing tools. By hovering our cursor over any tool icon, we will be presented with a simple pictorial simulating how to use the tool, as well as the name of that tool and how its command would be displayed in the command line. Before we begin drawing, we first want to verify the units of measure currently set to be used in this drawing. As noted in the previous video, inspecting the units settings of drawings we receive from other sources is recommended. When typing a command, it is not typically necessary to proactively activate the text cursor in the command line. The software simply interprets the typing process as the user's intent to communicate and input a command, and the text the user types will automatically display in the command line. Typing the command units and pressing the Enter key prompts the Drawing Units dialog box to open. Within this dialog box, we set the desired units of measure for length, for angle, and the base units of measure, also called the insertion scale, and units of measure for lighting. Decimal units of measure for both length and angle is set by default. In the left-hand column, where we adjust the units of measure for length, left-clicking on the contextual menu arrow presents us with the various units of measure used by different design and engineering disciplines. We will select architectural from this pull-down. Just below this is where we set the value of precision limit we want the software to use and display. We can think of precision as a rounding factor. That is to say, if we set our drawing unit's precision at 1/4 inch, any displayed unit values fractionally smaller than 1/4 inch will be rounded up or down to meet this precision setting limitation. We will explore later where setting a higher precision value can be problematic. In order to allow the software to provide the user the greatest amount of accuracy, we will set our precision down to 1/256th of an inch. Keep in mind, even setting this drawing unit's precision down to the lowest fractional value the software offers, it is possible to actually generate drawing irregularities that are smaller than this value. As we are working in imperial units, our insertion scale or base unit of measure is inches. In the right-hand column, when we expand the degree angle unit type pull-down, we are presented with the common angle measure of units used by the different design and engineering disciplines. For typical drawing and drafting purposes, decimal degrees is acceptable. Only if the user anticipates incorporating any angle of degree lesser than a whole degree unit, it is advised to not apply any decimal value of precision. Conversely, and similar to the discussion regarding precision values for length measurements, for example, creating a geometry that has an actual angle of measure of 22.5 degrees, when an angle of degree measurement is applied to this geometry, the displayed measured value will be rounded up to 23 degrees. Since the overall unit of measure value for angles is lacking a less than whole degree decimal precision setting. It is possible to set an angle precision value out to 8 decimal places. We will visit the impacts of these precision settings further when we review sizing of text, creating text styles, creating dimension styles, and applying dimensions to our drawings. To exit this dialog box, we can click the X in the upper right corner or click the OK button at the bottom left. As we have just made a drawing setting change to the default AutoCAD drawing template file opened by default and currently open as Drawing 1, let us save our drawing by invoking the Save As command, either by selecting Save As from the big red A pull-down menu, selecting the Save As icon in the toolbar at the top left corner of our display, or by typing Save As down in the command line and pressing the Enter key. Once the Save As command is invoked, we are presented with the typical File Structure dialog box. Let's save this current drawing as My Drawing, leaving our .dwg AutoCAD drawing file format, and let's save it to our desktop. Ideally, each user will have in place a file management system for organizing and keeping track of drawings and project data. Once we complete the steps of modifying the drawing settings to our own personal preferences, we will then take the opportunity to save this personal file as a drawing template file, a file with a .dwt file extension, and place it in the AutoCAD templates folder. We will then also modify the default new drawing file path in the Options dialog so that each time we open AutoCAD, our drawing with our preferred settings, etc., will be opened. If we created our personal .dwt drawing template file at this point, we would need and want to update this .dwt template file each time we make a future global user setting change. We don't always remember to do this, so making waiting a temporary and better option. The last area of our display to be explored that contains important user drawing drafting settings is in the bottom right corner. Starting from the left end of the row of icons is an icon named Model. This icon is not to be confused with the Model tab located in the lower left corner of our display. We will visit the relationship between this model icon and the Model and Layout tabs at the lower left in our next video. The next icon to the right is the grid icon. The grid icon toggles the background drawing grid on and off. And as is true for all icons across the bottom right of our display, an icon that displays as blue indicates that the drawing drafting aid is active. An icon that displays as gray indicates that the drafting aid is inactive. The background drawing grid is a visual aid only. The F7 key will toggle this tool on and off. To the right of the grid icon is the Snap Mode icon. Snap Mode is a drawing drafting aid that limits the spacing distance the drawing cursor is allowed to move. Think of it as incremental movement. Left-clicking on the pull-down arrow next to the Snap Mode icon reveals that we can control the incremental movement of our cursor in a grid or rectilinear manner, or in a polar or radial manner. Left-clicking on the Snap Settings text opens up the Drawing Settings dialog. In this dialog box are tabs for many of the other drawing and drafting aids icons found in this toolbar at the bottom right of our display. In the Snap and Grid Settings tab of the Drawing Settings dialog, our snap settings are set to 1/2 inch equally in the X and Y drawing directions. Close the dialog by clicking the OK button, and let's quickly explore how this tool can help or inadvertently hinder your drawing tasks. Left-click one time on the Snap Mode icon to activate Snap Mode. The icon should be blue. Upon entering a drawing type command, we will use the line command for this exercise. Note that now your cursor moves about your workspace, yet it jumps or snaps vertically or horizontally in 1/2 inch steps or increments. If this is advantageous to your drawing task, then activate this tool. Otherwise, this tool is best left inactive. Simply left-click on the Snap Mode icon to disable the tool. Pressing the F9 key will also toggle this tool on and off. The next icon to the right is Dynamic Input. This tool provides the user the option of entering coordinate and angle information in a more heads-up display fashion as opposed to referring to the command line for data input. I have found that the floating dynamic input boxes sometimes cover or interfere with objects I am wishing to work with, and also find them to be generally distracting. Some users really like this tool. I leave this tool disabled. This is an example of how each user has options in managing their work environment. The F12 key will toggle this tool on and off. The next icon to the right toggles orthographic mode on and off. This tool limits cursor movement to the x-axis, left and right, and the y-axis, up and down directions. One can also interpret these as the 0 and 180 degree and 90 and 270 degree directions. This tool is extremely helpful in ensuring that all linear geometry drawn horizontally and vertically are always truly horizontal and vertical. Unless there is a specific reason to be drawing an element in a direction other than the 0, 90, 180, 270 degree directions, keeping this tool always active is recommended. The F8 key will toggle this tool on and off. The next icon to the right is Polar Tracking, a tool that assists in constraining or restricting cursor movements to specific radial directions. Unless the user's drawing task requires these limits, this tool also is best left inactive until needed. The F10 key will toggle this tool on and off. The next icon to the right is Isometric Drafting. The pull-down menu allows the user to specify the drawing or drafting plane relevant to the orientation the isometric geometry is required to be placed. Unless the user's drawing task requires these limits, this tool also is best left inactive until needed. The next icon to the right is the Object Snap Tracking tool. This is an extremely useful tool and is recommended to always be active. This tool allows the user to reference snap points on existing geometry and to align new geometry. The F11 key will toggle this tool on and off. The next icon to the right is the Object Snap Tool icon. Object snap points are specific given locations on or relative to a geometric object or profile. The F3 key will toggle this tool on and off. Let's review recommended settings for these object snap settings for the average user. To lend clarity to this review, let's use a random line a rectangle, a circle, and a dimension string. Each object snap, when detected, is represented by a specific geometrical visual cue. In order to prompt the software to detect an object snap, we need to be in a drawing command. We will use the line command for this exercise. Every geometric object segment, except for circles and ellipses, have starting and ending endpoints. Every arc segment, every linear segment along a polygonal shape, every line segment have starting and ending endpoints. Note that it is not necessary to actually physically go and touch a snap point. The software will indicate any given snap point when you are within a certain distance of that snap point location. There is a certain level of trust value the user must develop to trust that when the software presents a snap point, and in this case I choose enter, that the software will snap, in this case my line segment, to that snap point that was detected. Likewise, every geometric object segment, except for circles and ellipses, have midpoints, which are signified by a green triangle. Both the endpoint and midpoint object snaps ideally are always on. Center points will indicate the center location of circles and ellipses and are represented by a green circle, often accompanied by a white plus sign. Note again that the cursor is at the circumference of this circle, yet the center snap location is clearly indicated. Geometric center snap points occur at the center of closed polygonal objects, such as this rectangle, and are represented by a white asterisk. Nodes are represented by a circle with an X through them and indicate the location of definition points, the measured points on dimension strings, points, as well as other objects such as mtext, paragraphical text, the corners of those paragraphical text objects. Quadrants are the 3 o'clock, 12 o'clock, 9 o'clock, and 6 o'clock locations along the circumference of circles, ellipses, and arc segments, and are represented by green diamonds. To review to this point, the endpoint, object snap, midpoint, center, geometric center, node, and quadrant object snaps ideally should always be on. The extension object snap, unless needed, ideally should remain off. The extension object snap allows us to detect an object snap of a linear segment and or an arc segment, and then to project into space where that line segment or arc segment would extend to. One possible use for this extension tool would be to use in combination with the Object Snap tracking tool to allow us to locate where our line segment would intersect with a vertical line extending from the quadrant of this circle. The intersection Object Snap is represented by a green X and will be displayed where geometry intersects other segments of geometry on the same Z plane. The insertion point Object Snap is represented by a pair of offset green boxes and indicate the insertion location of objects such as blocks, text, and other attribute objects. The perpendicular Object Snap is represented by a green perpendicular symbol and indicates when a linear segment is intersecting another linear segment at a perpendicular or 90-degree angle. The tangent Object Snap will indicate along a arc, ellipse, or circular object when we are intersecting that edge at a tangent point. The tangent Object Snap ideally would be left off and only activated when needed. The nearest Object Snap recognizes every point along any geometric object and, quite honestly, provides way too much feedback and makes it difficult and confusing to detect other object snaps within your display. The nearest Object Snap should always be off unless needed. A helpful tip to remember is that our drawing environment can often get a little crowded, making it difficult to get the software and the cursor to recognize the Object Snap point we are seeking to reference. By typing the first 3 letters of the Object Snap name, we'll isolate the chosen snap point style, ignoring all others. We'll examine an instance of this in our next video. The next 4 icons along the bottom are all related to annotative scaling settings. Annotation scaling is a tool and a means of allowing the software to control the display of annotative objects, such as text, dimension strings, leaders, attributes, and other objects. We will visit this more when we explore the relationship of annotative scaling and the display of annotative objects in our page layouts in our next video. The next 4 icons relate to annotative scaling. Annotative scaling is a useful tool and a means of allowing the software to control the display of annotative objects such as text, dimension strings, leaders, attributes, and other objects. We will visit this more when we explore the relationship of annotative scaling and the display of annotative objects in our page layouts in our next video. The next icon to the right is workspace switching. In addition to certain preset workspace settings, this tool allows the user to create custom user workspaces to fit their personal drawing and drafting needs, or the custom needs of certain drawing and drafting projects. The next icon to the right toggles the annotation monitor on and off. The annotation monitor displays a yellow badge on dimensions that have lost associativity. For example, the locations at each end of a line segment that a dimension string was originally referenced to have become disconnected from that dimension string. If this occurs, these little yellow badges will show up on your screen and prompt you to reassociate the dimension string with the original object. This is a helpful tool for certain drawing and drafting needs and unnecessary for others. The next icon to the right allows the user to lock the user interface. This is a helpful setting once the user has their workspace and display layout arranged in a manner that is comfortable and productive for them. The next icon moving to the right is Isolate Objects, a duplication of the Isolate Objects tool we visited earlier in the right-click contextual menu. In review, as a drawing develops and more objects occupy the workspace, this tool allows the user to temporarily isolate or separate out singular or a select group of objects to make modifying them visually easier. Once the user has completed working with the isolated objects, left-clicking on the Isolate Objects icon and choosing End Object Isolation unhides the hidden objects. At the bottom right corner is the Drafting Settings and Tools Customization palette. Each of the tools displayed in this palette can be added to or removed from the Drafting Settings toolbar that we have been reviewing at the lower right-hand corner of our display. This completes our tour in navigating the interactive portion of the user interface. Our next video will focus on invoking commands, creating geometry, and how to make the best use of the drafting and drawing tools we have just reviewed.